All right, 12.2 arithmetic sequences, day 3. Here we go. So we're still working on writing a rule for the nth term of a sequence, but unlike last week where we actually saw the sequence of numbers listed out as a pattern, today we're going to deal with other given conditions. So we're not actually going to see the full sequence, but we're still trying to write a rule for the nth term. So from last week, what we might remember is we were using this general form that a sub n, that's the nth term, whatever comes next, is equal to the first term, and then it was plus or minus that common difference, and then how many times did you use the common difference, which was n minus 1, to get you from the first term to the nth term. You had to add that number over and over. So here we're given a common difference. D is 3, that's great. And you drop a 3 right there, it means the only thing we need, remember in the end, a sub n is going to stay that way. It's going to be a sub n equals, and all the details go on this side to show us how can we find the nth term, whatever it might be. So what we really are after now is the first term. They didn't tell us where this started. But if we know where we ended up at the 19th term, and we know how we got there using a difference of 3, we should be able to solve for the first term. So I'm going to go ahead and drop in that a sub 19 is 48. And equals, now a sub 1, that's what I'm trying to find right now, so I'm going to leave that as a variable. On the other side over here, I do know the common difference was 3. And in fact, for n, since I replaced the nth term with 48, which was the 19th term, then 19 can go right in there as well, 19 minus 1. So at this point, you'll notice everything's been replaced with numbers, and a sub 1, the first term, is the only variable left. So we should be able to solve for this in just a couple of steps here. Starting on the right side, we can do 19 minus 1 is 18. And then ultimately, 3 times 18 is 54. And then if I just do a minus 54 on each side, we'll clear that out, do a minus 54 right there, you'll get negative 6 equals a sub 1. So there's that first term is negative 6. Now again, to actually write the rule for the sequence at the end, we need two things. We need the first term, and we need the common difference. And now we have both of them. So I can go back to this general format here and write that a sub n equals, now a sub 1 is going to get replaced with negative 6. Plus, since it was a positive 3, times n minus 1. And that is the rule for the sequence. You could technically stop there, though you'll see that our book often goes ahead and simplifies this. So I'm going to do the same, and that's or the simplified version. I'm going to do the 3 times n up front, so that's 3n. And then this would make 3 times negative 1 is negative 3. But then there was also a negative 6, so it's negative 6 and negative 3 makes negative 9. So you can get a simplified version of 3n minus 9. Of course, at the end, we could verify that this actually works, because now it's like, well, what if I want to find the 19th term? And if you drop a 19 right in there, 3 times 19 is 57. 57 minus 9 is 48, and sure enough, the 19th term is 48, just like we knew. So that's a quick way to check and make sure it all works. So we're going to do one more example today. And this time, instead of giving us some term and the common difference, it's what if they just give us 2 terms? We don't know the common difference. We just know, and we don't know how it started, which are the 2 things we need. We just know that the 8th term was 21, the 27th term was 97. So there's a couple different ways we could do this. The way I'm going to recommend and show in the notes here is a modified version of what we just did up here. That links the first term with the nth term. So I'm going to start by writing that down again. And that's a sub n equals a sub 1 plus d times n minus 1. Now, what I realized this time is I don't know the first term. So this isn't that helpful. And I don't know the common difference right now. So at the moment, the way this is written, it isn't exactly what I need. But what I realize is it isn't just used for the first term. It can be used for any other term as well. When I realize that it's just linking, the way 2 terms are related is that to get from one of them to another, you use the common difference, and notice how it's n minus 1. That's n, the new term, minus 1, the old term, n minus 1. So technically, that could be any other number, not just a 1, and it would just be like n minus whatever that is. So I'm going to right below here write a modified version of this that's basically the same idea, But instead of being specific to the first term, I'm now going to say it's any other term. So this represents any two terms in the sequence. And the way you can get from one to the other is instead of n minus 1, now it would be n minus m. That's how many times you'd use it. Now I have all values that I know. So for a sub n, I'm going to use the later term, the 27th term, which is 97. So I'm going to put it in sequence format first. That's a sub 27. And it's equal to a sub 8. But to get from a sub 8 to a sub 27, we used the common difference. Now we don't know what that common difference is, but we must have used it 27 minus 8 times. That's to get from the 8th term to the 27th term. Now I'm going to go ahead and actually drop the values in here. So a sub 27 is 97. A sub 8 is 21. And over here I'm just going to do a couple things to write this in a neater way. When I do 27 minus 8 and I get 19, well, instead of d times 19, I'm going to write that as 19d. So there's the 27 minus 8 where I got the 19. The d is right there. Now I can do a minus 21 on each side. And if I do minus 21 right there, I get 76 minus 21 right there, so it goes away. Now I just have 19d. Finally, divide by 19 on both sides, and we're getting somewhere here. We found our common difference is 4. Now remember from before, to write a final sequence, we need the common difference, but we also need the first term. So at this point, we have the common difference. We still need the first term, but now this makes the rest of this problem a lot more like what we just did up here. You're basically going to pick whichever one you want. You can use the 8th term moving forward, or you can use the 27th term moving forward. And it won't matter which one you use. You had to use both of them to find the difference, but now you can just pick one of them. And so I'm going to pick the 8th term just because it's smaller, closer to the first, smaller number, that kind of stuff. So I'm going back to basically the previous example where a sub n equals a sub 1 plus d times n minus 1, because now it is all about finding that first term. And again, I'm choosing to use the 8th term moving forward. So it's a sub 8 equals a sub 1 plus d times 8 minus 1. And since I know a sub 8 is 21, and then 8 minus 1 is 7, again, I'm just going to switch that around. Instead of d times 7, I'm going to do plus 7d. Well, now I'm basically at the point where I can put that common difference in there. Now that I know the common difference is 4, then I can see that as 7 times 4 is 28. So we must have started at something, added the number 4 7 times, we added 28, and we ended up at 21. Well, if you do a minus 28 on each side, then you'll get negative 7 equals a sub 1. And so there's that first term. And all you need are the first term and the common difference to now write that a sub n equals a sub 1 plus d times n minus 1. So this time that would be written as a sub 1 is negative 7. And then plus the common difference 4 times n minus 1. So that would be a fine stopping point for this. But again, as our book keeps going and gives the simplified version, then I'm going to say a sub n equals 4 times n makes 4n up front. That also makes negative 4 in the back. 4 times negative 1 is negative 4. But then don't forget there was a negative 7 here as well. So that's negative 7 and negative 4 makes negative 11. And there's a final answer for that one. So once again, you can check at the end by picking one of the terms they gave us to start. I'll pick the 8th term and just make sure it all fits together. When n is 8, a sub 8, put an 8 right there. 4 times 8 is 32, and 32 minus 11 is 21. So it all fits back together, and we know that this works. So that's all for today. At this point, you can go ahead, work on just a couple practice problems today on page 806, 807. It's number 23 and number 31. Also, I just wanted to point out, I said there was other ways to do this problem. So if you were interested, you can check page 804 in the book, and they do show a different way. So this is the way I prefer. I just think it's a little easier. But feel free to check page 804 in the book, and you can see another way to do this. Thank you all so much.